Welcome to Module 2, Access Controls. In this chapter, we will be looking at access controls, the categories, physical access controls, the devices involved with this, as well as logical access controls. When you think of access control, think of any controls that give you access to things that you care about, as in your assets, your computers, your servers, your workstations, anything of value. It has information on it. There's configuration that could be considered, private, that we don't really want just anybody to have access to it. The way that we control the access normally would be done through who you are, your group memberships, which could be based on your job function. Many times we have that, which we call job roles. It could be based on security clearances. You have top secret and secret, as well as need to know. If a user wants to have access to information, they can't just have it because they want it. It has to be a reason. Their job has to basically spell out, I need this information to perform my job duties. We also look at physical and logical location that could dictate access. Perhaps you have to be within the facility to have access to certain information and not overseas trying to remote in. We also look at controls that we put in place to try to protect our information and control this access. With these controls, we can dictate who can have access. We want to avoid unauthorized access or disclosure of information, unauthorized someone getting into the system and corrupting what we have or destroying it, or even making changes that they never had the right to do. And as we continue these definitions, subject, when you think of the subject, that's who's doing the accessing. That a lot of times would be the user. They're the active entity accessing the object. A user or even a group of users could be considered subjects. Also, it could be a software program that is trying to access some sort of folder, and this folder or this printer, we would consider that to be the passive entity called an object. So the subject, the user, the group of users, or possibly a program accessing another object, such as, again, folders, files, printers, anything of value, they're considered objects. And what you're allowed to do with those objects is based on your access. That's something you could do. Could be, I can read the information, I can delete the information, create new information, maybe run programs through execute. And this whole concept of controlling who or what has access to these objects, these subjects having access to objects, is called access control. Many times we might relate to that as permissions. So when you look at your access privileges, especially in Microsoft, we think of the term permissions, and that would spell out what you're allowed to do as a subject to that object. And of course, spelling out, what situations you might have access to that, and it could be based again on job role. So another term, access rules. With access rules, they're basically specifying you, the subject's access rights, what you're allowed to do, and this could be controlled through software. And then also access path that request travels through. And that could be through and controlled through software, is what they're saying here. Concerning access controls, we have physical, technical, administrative. Physical, I think, is one of the easiest ones to look at. You can kind of identify with, I've got to get through that lock because I can't get past that door because the lock's preventing me from getting to where I need to go. Maybe there's a room full of computers and I'm trying to get in there, so we have some sort of physical control to keep those out that really don't belong in that area or shouldn't have access to that area. Maybe we used to use floppies, and there could have been some physical control on that, or some lack of access to a CD-ROM, and because there's actually something preventing you from accessing that. How about security guards? Security guards can keep you from entering an area because they would check your identification. They may be armed as well. There could be locks on the computers to keep people from opening up the computers at night and trying to, maybe do some modifications to the computer to take RAM out of the machine or to steal the hard drive with data on it. Technical controls, also known as logical. When I hear that, I think of computer people and computer engineers and such, because that's something we as computer people might implement. We would think of encrypting the data to keep those that are not allowed to read it and away from it, where they can't really translate it or understand it because it is encrypted and they have to have the decryption keys. We could password protect. We could use biometrics to actually identify you. There could be something we do in the operating system to control access as well, and through these logical controls we could have the user log in and show the identification and then finish the authentication, and which would lead to the authorization, in other words their permissions, what they're allowed to do. Administrative, that sounds more like something from a managerial perspective. When you think of that, you think about policies and procedures that managers would put in place. And of course, with these, the policies would be the high level, perhaps security goals, and procedures could be the step-by-step details of how we implement this. We would also run security awareness training with our users, because that's something that you don't just do once, you repeat, because users need to be very aware of security and they tend to forget. And of course, good just basic quality assurance. More on physical controls. Again, these are some of the easiest ones to really think of. Maybe the walls are made of materials that are very hard to get through. Maybe your doors are rather robust as well with great locks. Security guards that are armed would be definitely a deterrent. Or maybe you see dogs sometimes being used to guard areas. Fencing. Some fencing is more intimidating than others. Fencing that's quite tall, maybe 8 feet with barbed wire. Adequate lighting can be a good way of seeing an intruder, as well as deterring an intruder. Of course, we looked at locks. They come in all kinds of different types. Cipher locks, regular lock with key. Environmental controls are all part of physical controls. And we have heating, ventilation, and air conditioning that we'd have there as well. Intrusion detection systems, we're going to see quite a bit on this too. They could detect that someone's actually come into your area and trying to maybe get into a jewelry store. Logical controls, back to the computer people, technical. We as computer people would implement firewalls. We could do software firewalls, we can do hardware firewalls, and it's built into the operating system of Windows. We have third-party ones we can use. We also have intrusion detection systems, which would detect intrusions, but not of the physical nature. More of something that resembles a hacker. Encryption, we like that. Encryption keeps information that's sensitive, where it's not readable by those that cannot decrypt it. There's protocols. We have TCP/IP. There's authentication methods that we can use, whether it be username and password. Maybe using a secure ID device with an actual number you have to type in and you carry a physical device. That could be biometrics. We have auditing. Auditing, you can actually look at logs. Windows has some logs built into it, and they can be security related even. And just anything relating to access control that we implement as regular computer people. And then when you think administrative, also known as soft controls, you think management. Okay, again, policies, high level, procedures, step by step, standards, something we're required to follow, guidelines, optional. Essentially, policies, procedures, and standards are all actually mandatory, and guidelines are optional. They're basically recommendations. When you think of employee management, we have tests, and we have drills. You can even think of a fire drill. going through the motions on that, analyzing risk to see if there's anything we can do to protect our, our assets, our network, our data. We can classify data, especially if we're in an area that's like of military nature or government nature, where you look at secret and top secret. And security awareness training, it has to be repeated. The users, I think, need a gentle reminder. As far as security roles go, we have the data owner, and the data owner is responsible for a portion or a subset of data in data classifications. And then we have the system owner, and they're responsible for certain computers. And actually, one system could have more than one system owner. Okay, it can hold data from several system or data owners, you might say. So there could be several data owners for the one system. Data custodian, think of them as doing maintenance task. User, just anybody else, just a regular user. When we think about accessing or granting access, first we go through identification. Who are you? It could be some proof like identification card that you have to show, or in some cases it might be nothing more than, a username. And to complete this authentication, we would have to have another piece of information. It could be a password, could be combined with some other method like a secure ID, typing in a one-time password, or maybe using some sort of biometric to kind of finish it. But a lot of times it's two parts. It doesn't mean two factors, but two parts. Who are you? Prove who you are. Complete the authentication because you have the rest of the information to go with it, like what is your username, what is your password. That's identification, authentication. Authorization, once we know who you are and you've proven that, we can actually look at your permissions. And your permissions basically dictate your authorization because it spells out what you're able to access based on those permissions. What files, folders, what printers. Access criteria. We have security clearance. You think of military with mandatory access control systems. They have what they call security labels. We label the information to a certain clearance level. Top secret, secret. We label the people as well with clearance levels if they require the clearance levels. And of course, if there's not a match on those clearances, they're not allowed to see that information. Need to know, which can be formal or informal. But with this, it's not really good enough that you necessarily have the clearance to see the information. Do you also have a need to know that information would also be looked at. Least privilege, with this concept, giving people the access that they require and nothing more. Give you just enough to do your job, yet nothing beyond that. And of course, when we move people from one department to another, we want to make sure that we take them out of any sort of groups from the prior departments or prior job functions that give them privileges that they no longer need. Now, if we have someone who's part of accounting, then they move to human resources, maybe then they move to another department, we don't want their permissions to just follow them and just keep accumulating, keeping the accounting permissions, keeping the human resources permissions as they go along, accumulating them, which is basically authorization creep. We don't want that. Default to no access. With permissions and also firewalls, it's preferable to default to no access. So in other words, if we do not give you these permissions, you don't have them. You are understood to be denied, implicitly denied. Physical access control mechanisms. We can actually use things such as biometrics, and we'll see a slide coming up on biometrics. Biometrics are pretty interesting. Retinal scans, fingerprints, voice print, it goes on and on. Token devices. These are devices that we can actually carry with us. They come in two forms, synchronous and asynchronous. Memory cards, think of your banking ATM card or proximity card. We see those at hotels. Smart cards, military, governmental type people tend to use these pretty often, really. And with these look like, they could be in the form of something that looks like a credit card. It could be in the form with the military of something that appears to be an identification card, but yet it has intelligence. And of course, cryptographic keys are used in many places as, the private key, where you have a public and a private key. With biometric systems, we aren't going to go through every single one of these, but as far as pretty popular ones, a lot of times you'll see some sort of one relating to fingerprints, fingerprint or fingerprint scan. There's been a lot of talk of iris and retina scans. Now, the retina scans, these are interesting. These are the blood vessels on the back of your eyes. And then the iris is the colored part of your eyes. When you say that person has blue eyes, that's the iris that you're actually looking at. Unfortunately, there's some personal health issues that can be revealed, especially with a retina scan, reading the blood vessels on the back of the eyes. Dynamic signature or keyboard, that could be the way you type, the way you sign your signature, the actual pressure and speed. Maybe voice print, the way you talk. It's the hand geometry. There's a lot of interesting biometric ones. When you start thinking about token devices, these come in two forms, and this was first looking at synchronous token. And this is where it actually synchronizes based on a time or an event. So the token device and the authentication service is what's actually being synchronized. And with this device, as you can see, we'll actually display some sort of, most likely a number, some sort of password on the device. And then the user types in the value and identification information relating to them, and it's part of their login. If it matches, it's accepted, otherwise it's not. But essentially, when you say synchronous, you could just simply think time. It synchronizes with something such as time. Or it could be more based on a challenge response system, which is asynchronous. It does not sync up based on time or event. Value is sent from the authentication server to the user, and then the user enters this value into their device. Then that device will hash or encrypt that value and provide the results to the user. And it's essentially a one-time password. And of course, if it's the expected value, they're authenticated. If it's not the correct value, they're not. Memory cards. We don't really go around calling them memory cards, but that's what they are. You start thinking about going to your bank and using your ATM card. It doesn't really have any built-in intelligence. It's not really considered a smart card. But essentially, the banking ATM system is able to read that. If you think of examples like proximity cards can be in this form, credit cards, your ATMs especially. As long as we have a reader, it can read that, and we put in additional information such as a PIN code for at a bank. Smart cards. These actually hold intelligence. These are able to hold and process data, unlike their memory cards. And they consider it to be a tamper-proof device. And you would put a PIN or a password also with this one, just as before, to unlock that functionality. And as far as what is it you could use it for, holding biometric data in a template, responding to a challenge, how about a private key? Or holding a user work history, medical information, etc. And this is actually pretty common, like I was telling you, in the military environment. Military and governmental systems, they can actually use these smart cards, which they call common access cards, as identification, maybe to get on a base. Then they can also use these cards to insert into a reader with their computer that they're using to identify themselves. So instead of putting in a username and a password like we do for many functions of logging in, they have to put this card into the reader and then put in additional information such as some sort of PIN code to go with it. Cryptographic keys, that's pretty generic. We see authentication that may require some sort of cryptographic mechanism. And with this, we're talking asymmetric cryptography, which means a public and a private key. Examples are showing here is using the private key, which again, military use a lot of the public and private key concept for many functions. How about digital signing? They could digitally sign a document. They're encrypting a hash value with their private key, and they do not have to pre-share any sort of keys like you would with the symmetric world. So it's really a system that they have the private key and the systems and others have the public key, but obviously we keep our private keys private. Logical access control. Application level, such as a shopping cart or a content management system site where you have a user interface. Middleware level, think of a database working between your operating system and any sort of applications that you're running. Then at the operating system level, we think of the various operating systems such as Windows, Linux, the Macintosh with the Apple operating system. I mean, it could go on. And then finally down to hardware level even, controlling logical access. Operating system access controls. When you think of this with the operating systems, we control access through group memberships, sometimes stated as roles, because you could actually have groups based upon roles, and these roles could be job function related, the secretary role, the manager role. An access control list, which that term is used dealing with permissions such as NTFS permissions. Access control list can also be used on as firewalls on a Cisco router, for example. Now, dealing with the Linux side, we're looking at groups, roles, and access control list, and trying to get an understanding of permissions in the Linux world. Accounts and groups. Now, in the Linux world, accounts are created and managed using a password file, and this is held in the /etc/password file. And you will find that there are user accounts listed there. Each line will actually show this. And they do have commands such as add user to actually add users from the command line. We can also change the password with the passwd command followed by the username. And there also is a shadow file additionally, and with the shadow file, that's where the passwords are actually hashed, where they're essentially not in a readable format. But the password file, it is word readable. So to encrypt our passwords, that's why we have the shadow file. And when we look at the etc password file, we will see an X where the password would have been to represent the fact that the password is actually displayed in an unreadable format in a shadow file. Now, each Linux distribution has some differences, but basically you can see you have some control over the shadow formats, and there's some commands that can be put in place with that. But looking at this, they're showing in the middle here, etc password, and we can see that there's a person, Smith J, and we can see his name is Joe Smith, and then we see a little bit about his home folder and so on. But there is an X. This X that is displayed here, right there, is essentially a representation to let us know there is a password, but it's not displayed here. That we would go to the etc shadow file, and this would be where the password is contained, but again in a format that would not be readable. We can also get other details such as account expiration and so on. Accounts and groups. Within the password file, we have login name, encrypted hash password, UID number, default GID number, Gecko's information, home directory, and login shell. The Gecko's information, when you're looking at that could have further details. It actually stands for General Electric Comprehensive Operating System, but effectively it's more of sort of a comment field. It has additional information there. And groups, just like Windows, we would use groups in the Unix and the Linux environment. This information is also stored in the /etc/group file. So very similar to what we've seen. There's a trend here. etc password, etc shadow, etc group. And the group can have various information also, the group name, encrypted or hashed password, GID number, the group members. Password area is never used here. Now with the Linux environment, realize that there's an account called root. Root is like admin or administrator, or back in the Novell days, supervisor. And this is the account that has the most power. Now we generally log in as a regular user, and if we need to do something of a higher credential, we could actually do a command like sudo, and essentially sudo followed by what we're trying to do, and it knows that we want to act as root. And because root has all the power. It's generally best with all systems, including Linux, Windows, and so on, to make it a habit to log in as a regular user, because we do not want any malware to try to run in the power level of root or admin. And if we make it a habit to log in as this more powerful user, malware could potentially take advantage of that. Now, permissions are quite different. Every file does have permissions, and every file has an owner and an owner group. And the root user and the owner can access the file. There's 3 different areas. You'll see owner, group owner, then everyone. With permissions, they're much more simplistic. Read, write, and execute. With these permissions, there's different forms in the way you can actually do the permissions. You can actually do a listing, just like we would in Windows with the dir command, directory. We could actually do ls, and that's kind of like dir in the Windows world. Just an example here in this next screenshot, ls-l. This gives us great detail here. And we can actually see the 10 characters. And if you see the letter D, which we do with the folder called desktop, we realize when we see D, that stands for directory. Now for you Windows people, realize that you don't usually hear the word directory so much anymore. A long time ago, we called everything a directory or a file. In other words, files within directories. We didn't use the word folder till later, but effectively a folder and a directory are the same thing. And with this, when you look at these permissions, you actually have groupings. And with this, realize after the D, we'll look at the one that says LIDA. LIDA, it is a directory. And then you have RWX, read, write, execute. That is effectively owner. And then the next 3, which there can be dashes in there. So you got RWX, then we have R no write X. That would essentially be the group, the owner's group. And then the third one is everyone, which looks like we've got read and execute only for that particular directory. If you see a dash, there is no access given there. Realize the format is read, write, execute. So again, the owner had read, write, execute for LIDA directory. Then after that, we had R-X, so it means read and execute only for the group. And then they repeated it, R-X. That is for the everyone. They call it the everyone account. Dealing with these Linux permissions and Unix permissions, we can use a command called change mod that will change the permissions for your different users. Now, these can be done in different formats, and we need to also understand how to do this in an octal format, because there's other ways besides read, write, and execute, doing it through letters. We can do it through numbers. And the concept is the same. It's just we're still given read, write, and execute potentially, but yet you're doing it from a numeric perspective. And at first glance, it looks kind of funny. Change mod 745. I mean, what does that mean? Basically, when you look at the octal representation, you'll be able to see this. So you saw, I'm going to flip back and forth a few times. We have read, write, execute. That was a 7. Read, write, execute. So 1, 1, 1 is basically saying when you have a 1 in each column, I'm giving you read, I'm giving you write, I'm giving you execute. Then we saw, I think on the last slide, they had a 4, then a 5. 4 is basically a 1 in the read column, nothing in the write or the execute. So from an octal representation, that gives you just read. If you wanted to give you write, oops, sorry, go back one. Looking at this, we have, actually not right, I was mistaken, read and execute. You can see it, read, no write, execute. So this makes a 5. So this is the octal equivalent. So permissions can be given through the change mod command from an octal perspective, just like was done here, change mod 745. And if we understand the equivalence from this chart, then we just use the numbers. And that can be easier. Maybe I just want to give someone execute, make it a 1. If I want to give them just write, I give them a 2. Want to give them write and execute, I give them a 3. So it's pretty straightforward. Set UID programs. There can be dilemmas, if this did not exist, with how users could run certain programs that require a higher permission than they actually have. So as I put it here, how does a lowly user change their password without root level access? It's because of something called set UID. With the set UID, a program can be configured to always execute with the permissions of its owner. So this can be a really nice feature because you would not want to always have to involve the administrator guy for all these different simple issues that we run into. So we can actually find all the programs that have this set UID established, and it's set to run as root by commands such as these, and they're actually trying to find all programs that have this set to run with root permissions, which could be quite helpful to allow users to do basic tasks without involving the administrator or someone with greater power. Another thing, trust relationships. Yes, one user can be trusted by another, thus creating a trust relationship. And these trusts can be implemented using system-wide. We've got, there it is again, /etc/host.equiv file, or individual users could use something called .rhost files. So when you're using rhost, you need to use the Unix tools called R commands. You probably notice that a lot of the Linux commands start with R. And you can see a remote interactive command shell, a remote shell, a remote copy. It's remote something. And when you look at the /etc/host.equiv file, it contains a list of machine names or IP addresses that that system will trust. And a user can create also the .rhost file in their home folder or directory rather, setting up trust with other machines. So in this chapter, we've covered so many different things, ending up on a little bit of a slight Linux tutorial. We started out with access controls. We looked at the definition of access controls, the different types of access controls. We even looked at physical access controls in different devices, plus logical, middleware, operating system, and all the way down to the hardware.